Counting rules determine the number of possible outcomes that exist for a certain broad range of experiment. It can be extremely useful in determining the probabilities. So subtopic 2.4.1, the MN rules. This rule is a formula for counting the number of possible outcomes of a single experiment when sampling with or without replacement. This rule is used to fill k different slots. So in example 2.7, Amanda is going to furnish his house by ordering 5 chairs, 4 tables, 2 cabinets, and 3 beds. In how many ways can he make the order? So we have 4 different slots. And then for every slot, let's say the first slot is for chairs. So we have 5 different options. And then the second slot is for tables. We have 4 different options. And then the third slot is for cabinets. 2 different options. And then the last one, we have 3 different beds. So based on counting rules, for MN rules, we just simply have to multiply all possible options, 5 multiplied by 4, multiplied by 2, multiplied by 3. So there are 120 ways he can make the order. Okay, so for example 2.8, when ordering a new car, there are choices of interior. So there are 8 possible colors, and then for the next slot we have colors 10 for the interiors, and then the next slot we have 4 roof colors. So how many possible color scheme are there? So you only have to multiply 8 multiplied by 10 multiplied by 4. So there are 320 possible color scheme. For example 2.9, a local parents-teacher association PTA group is selecting committee members for the current year. There are 15 individuals in the groups to be selected as president. So the first slot is for president. Next one is for vice president, secretary, and treasurer. How many possible groups of committee members are there? Okay, so since we have 15 individuals, first we are going to select the president. So there are 15 different individuals can be selected as president. So let's say one person already selected to be the president. So the remaining individuals are 14. So only 14 individuals can be selected to be a vice president, because those who already selected to be a president cannot be the vice president. So that's why we have to minus from 15 individuals. We minus 1. So we have 14 for the second slot, which is for the vice president. So also the same rule applies to the third and the fourth slot. So for secretary, we also have to minus 1. So that means we have 13. And then so the next one for the treasurer, 12. So the answer would be, you have to multiply everything. 32760 possible groups of committee members. For example 2.10, how many 4-digit numbers greater than 3000 can be formed from digits 1, 2, 3, 4, 5 if repetition is allowed? So first of all, for the first slot we only have 3 possible value can be selected for the first slot? Because it is stated here the number should be greater than 3000. So automatically we cannot use number 1 and 2 for the first slot. So we only have 3, 4, and 5. So that's why for the first slot we only have 3 different digits can be used for the first slot. And then for the second, third, and fourth slot, it is stated here the repetition is allowed. So we have 1, 2, 3, 4, 5. So and then we have no rules stated in this question for the remaining slot. So we can use any numbers from the 5 digit for the empty slots. That's why for this case 3 multiplied by 5 multiplied by 5 multiplied by 5 equals to 375 ways. For question in example 2.11, how many 3-digit number can be formed? So 3 empty slot from the digits 0, 1, 2, 3, 4, and 5. If A, repetition is allowed. So remember, you can repeat any digit given in the question, but then the trick here, it is stated that 3-digit number can be formed. So if you want to form a 3-digit number, first of all, you cannot use 0 in the first place. Because if you put 0, and then we only use the next remaining slot, so let's say we put 0 in the first slot, and then 1 and 2. So this is not 3-digit number. This is actually 2-digit number. That's why we cannot use 0 in the first slot. So how many options do you have? We only have 1, 2, 3, 4, 5. 5 different digits can be used for the first slot. So for the next slot, there's no rule stated in the question. So since there is no rule, and then you can repeat the number, so that means we can use all 1, 2, 3, 4, 5, 6. So 6 number can be used here, 6 number can be used here. So the answer is 180 different numbers can be formed for question A. So for question B, repetition is not allowed. So if repetition is not allowed, but then you still want to use to form 3-digit number, so 3 empty space, no repetition. So since no repetition, but then still 0 cannot be used for the first slot. For question B, based on the question, it is still applicable. The rules for the 3-digit number is still applicable. So since you want to form 3-digit number, the same rules apply for question A and B right here. So you cannot use 0 for the first slot. So since you cannot use 0 for the first slot, you only have 1, 2, 3, 4, 5. So you only have 5 different digits for the first slot. But then, assuming that you already selected one number from the 1, 2, 3, 4, 5, maybe you select one number, maybe we select 5. So we only have 4, 3, 2, 1. But then for the second slot, 0 can be included. So still we have 5 different digits for the second slot. But then for the third slot, since repetition is not allowed, assuming that you already used 2 different digits, you only have, so 6 from 6 number, you already used 2. So the remaining is 4. So from the multiplication rules, you're going to get 100 possible ways. For question C, repetition is not allowed and then the first digit must be 3. Okay, since the first digit must be 3, we only have 1, 3 right here. So the possible option for the first slot 1, but then for the second slot, since we already use one number, so 3 cannot be included in the second and the third slot. So we only have 1, 2, 3, 4, 5. So 5 digit can be used for the second slot. So since we already used 2 different number for the first and for the second slot, so from 6 over here, we already used 2, so that means the remaining number you can use now is 4. So the answer is 4 multiplied by 5 multiplied by 1, so 20 ways, or 20 different digits, 3-digit number can be formed.